Okay, dear students, as the tradition says, after completing a chapter, we have to go through some past questions in order to solve some problems which might have not been solved throughout the chapter. Okay, first question will be June 2024, question 5 sub 3. The question says, consider the following array of colors to sort in alphabetical order. We have green, blue, yellow, red, white. For each pass in a bubble sort algorithm, use arrows to indicate how values in array cells are swapped. Then write out the array cells value at the end of each pass. Now what question A says for 4 marks. B. Show the array ranges during each stage of a binary search to find the color yellow in the sorted array in sub 3A above. That is from the array we must have sorted. Hint, the mid position is the integer part of its calculation. That's for 3 marks. So this sub 3 part is for 7 marks. Now, what do we have? Initially, we have green, blue, yellow, red, and white. And we know that for a bubble sort, we are comparing, we start from the beginning and we compare adjacent elements. So I'm going to compare green and blue. Then from there, I will compare the first and the second, second and third, third and fourth, fourth and fifth. I will repeat the statement until I'm going to have my sorted list. Okay. For pass one, when I compare green and blue, we realize that B, and because they say they are sorted in alphabetical order, so B is supposed to come before G. So I'm going to swap green and blue, meaning that blue will be my first value and green will be the second. So my second comparison will be green and yellow. When you compare G and Y, there is nothing to be swapped. They remain like that. I now compare the third and the fourth. When you compare Y and R, you see that you are going to swap. So that red comes before yellow. So red will enter this position and yellow will be at this position. And when you compare yellow and white, you see that W comes before Y, so W and Y are going to be swapped. So for pass one, these are the different values that are going to be swapped, and from there, this is what we are going to have. So initially, I had green, blue, yellow, red, white. These two were being swapped, as you can see. Yellow and red was swapped, and then yellow and white was also swapped. So you see that this is what we have after pass one, and we see that it is already sorted. So this list is sorted after one pass. So this is what we have: blue, green, red, white, yellow. Sorry. Now the B part, let us indicate the indices because it's very important. Remember that the B part is asking us to show the array ranges, and when you are performing a search or a sort, it is very important to use the indices. For this particular one, I use my first index to be 1. Any student who uses his or her index to be 0, her first index, his or her first index to be 0, the calculations remains the same. Okay, let's proceed. So what am I going to have? This is my first range. As you can see, this is my first range because I'm focusing on the sorted array. That's what they said. On the sorted array in sub 3A above until the sorted array here. So this is my first range. So value to search yellow, that's what you say in the question, to find the color yellow. So that's my value to search. My first range, this is here, blue, green, red, white, yellow. Middle value, we know that middle is lower bound plus upper bound. All that divided by 2. When you take 1 plus 5, that gives you 6. Divided by 2, that gives you 3. So the middle value is the element at position 3, which is red. So my comparison, I will compare yellow and red, and we see that they are not the same. And when the comparison with the middle element, there is no match, you now see whether the value you are searching is above the middle or below the middle. And when you compare letter Y and letter R, you see that Y is above R. That's why you have this conclusion that yellow is greater than R. And if our value you are searching for is greater than the middle value, it means that our searching range takes from the value after the middle till the upper bound. So our new range now will be white, yellow because this was our middle. The new range is the list, the sub list above. So this is our new range now. So range 2, white, yellow. Comparison, yellow and white. Now, let me tell you why it is white. When you take 4 plus 5, it gives you 9. Divided by 2, you have 4.5. And here they said the mid position is the integer part. And the integer part of 4.5 is 4. So our middle value here is white. When you compare yellow and white, there is no match. And actually, yellow is greater than white, meaning that our range now is this sublist, as you can see. So for range 3 now, I simply have yellow, and when I compare yellow, the value I'm searching, with yellow, the only value in the list, there is a match, and we return the index 5, as you can see. So we return 5 as it is the index of the element we are searching for. So guys, this is what was expected from you in June 2024 question 5 sub 3. Give the different ranges, you give the middle position, and you give what you have after comparison. So that's all for GC June 2024 question 5 sub 3. Next question is the Bamenda mock 2022 question 8 sub 1C. The question says complete the following trace table for the code below. We have passenger X. As you can see, it's an array. We have total initialized to 0. We have max number. We have a for loop, and so on. Dear students, when we were doing dry running of algorithms, we never went through an algorithm that has arrays. So I think this is a good opportunity for you guys to see how to dry run an algorithm containing arrays. Though it is not difficult and it is just the same, it's just for you to understand how to manipulate the indices used in the algorithm. First of all, take note that since this for loop x initialized to 0, I will directly assume that in this array my index starts from 0. Okay, let's proceed. Total equals to 0, that's what we have. Max number equals to 0, that's what we have. Now for x equals to 0 to 3, because index 0, index 1, index 2, index 3. So for all the different values in the array, what do we have? So for all these different values, I'm going to repeat all of this. Total is equals to total plus passenger at position x. So now, first of all, x is 0. Passenger at position 0 is 100, meaning that total is equal to total plus 100, which is 0 plus 100. That gives us 100. If total is greater than max number, then max number becomes total. When you compare total, max number, this condition is true because total is greater than max number. So max number takes the value of total. Next passenger simply means x becomes 1. So now when x is 1, I will have total. So I have passenger at position 1 is 300. So total will be equals to what? Total plus 300, which gives us 400. Is total greater than max number? Yes. So max number becomes total. Next passenger, which is negative 200. Total becomes total plus passenger at that position. When you add these two values, you have 200. Is total greater than max number? No. We go to the next passenger, which is 150. Total becomes total plus passenger at that position. That gives us 350. Is total greater than max number? No. And since it is the last passenger, we come out of our for loop because we executed for 0, for 1, for 2, and for 3 as it is stipulated here. So we are now out of this loop. We come now at this last position, which says that total carriage is equal to the integer value of max number divided by 100. Max number is 400. When you divide by 100, you have 4. And now output total carriage. That's what we have. So as I told you when we were having a similar example, when you are given a question to perform a dry run and a trace table is given to you, you are working only with that trace table. Nothing to add, nothing to subtract. So that is what was expected from students. The Bamenda Mock 2022 question 8 sub 1C. Center Regional Mock 2024 question 6 sub 3. Let A and B denote positive integers. Suppose a function cure is defined recursively as follows. That's what we have. So cure of A, B, these are the two parameters. 1 if B equals 0, 1 if B equals A, cure of A minus 1, B minus 1, plus cure of A minus 1, B, if 0 is less than B, less than A. That's what we have, dear students. Now, first of all, I would like you to answer this question. How many base cases do we have here? And how many recursive cases do we have here? Okay, you keep the answer for yourself. When we shall be evaluating question C, we shall come back to that. Solution. Cure of 6, 4. You realize that A As you can see, 6, 4 satisfy this condition because 0 is less than 4 and 4 is less than 6. So we arrive here. A becomes A minus 1. That way we have 5. B minus 1, 3. So when you take this minus 1, you get 5. You take this minus 1, you get 3. Plus cure of A minus 1, 5, and B, which is still 4. Now, when you look at this, cure of 5, 3, it still goes with this condition. Cure of 5, 4 still goes with this condition. So at this level, what am I going to have? This particular blue one will give me cure of 4 and 2 plus cure of 4 and 3. Whereas this will give me cure of 4 and 3 plus cure of 4 and 4. This is what we have, as you can see. So this blue gives us this, whereas this one gives us this. Now, this particular value, you realize that A is equal to B. And if A and B are equal, we should return 1, as you can see. Then you realize that we have like terms, cure of 4, 3, cure of 4, 3. So what are we going to have? Cure of 4, 2 plus 2 into cure of 4, 3 plus 1, as you can see. That's what we have. Now, we need to break down this and this again. What are we going to have? This blue cure of 4, 2, since it still satisfies this one, I'm going to have 3, 1 plus 3, 2 plus this one now 4, 3, 3, 2 plus 3, 3. Then this one is it here. Now, we realize that A and B are the same, so this is equally 1. These are like terms also. So normally I'm supposed to have this plus this is times 2 plus 1, that makes 3. So I'm supposed to have this plus 3 into this. This is 1 times 2 plus 1, that gives 3. So this is what I'm getting. This one is it here. Cure of 3, 2. Here I have 2. Cure of 3, 2. When you take this plus this like terms, it gives you 3. This is 1. 2 times 1, this is what we have. And this one, this is it here. So we get this blue cure of 3, 1 gives me cure of 2, 0 plus cure of 2, 1. Still using this definition, please let us be focused. Plus 3 into cure of 3, 2, still using the same definition, gives me 2, 1 and 2, 2. Then when you take this simple algebra, it gives you 3. We still have like terms here, as you can see, dear student, and this gives us 1. So this is what I'm having. Take note that cure of 2, 0, we said if B is 0, then it gives me 1. So this gives us 1. This and this are like terms. Here I have 3 into this plus this one, that's why it gives us 4. Then 3 into 1 is it, plus 3 is what I have. So now I have to evaluate this. Then I operate this simple algebra. So what am I having? 4 cure of 2, 1. Cure of 2, 1 will give me what? When you apply this again, you have 1, 0 plus 1, 1 plus 7 because this is 3 plus 3 is 6 plus 1, 7. This is what we have. And now if B is 0, 1. If A and B are the same, 1. So I will have 4 into 1 plus 1 other plus 7. Hence, cure of 6, 4 is equals to 15. Yes, 2 times 4, 8 plus 7, 15. That is what we have. So now the B part is saying, what does this function do? So dear students, can you tell me what this function is doing? If this was your answer, then you are right. The function cure for input A and B, where A is greater than or equals to B, as stipulated here, because this stipulated A should be greater than B, and here B can be equal to A. That's why I have this A greater than or equals to B. It returns A combination B. Now you ask yourself, how is it doing to know all these different ones? Dear students, one, I gave you in the notes under recursive function, I gave you all the most used recursive functions that we have. And another recursive function can be given to you, which I did not introduce in the notes. Now, how do you do to identify what a particular recursive function is calculating? From the number of inputs, you need to ask some questions to yourself, and especially you need to be very good in maths. That is, if I'm having A and B, what are the different operations I can perform on 6 and 4 to have 15 as answer? Addition, no. Multiplication, no. Subtraction, no. Division, no. Then look at other functions that can be performed on two numbers to have the answer you have. Is it permutation? Is it raised to the power? Is it the n root? Is it combination? These are the questions you must ask yourself. If it is one input, you ask yourself, is it factorial? Is it Fibonacci? a lot of them. So that's how you will easily know about what a recursive function is computing. The C part is asking us to write an algorithm in pseudocode for the recursive subroutine cure. And with the steps in writing the algorithm for a recursive subroutine, what do we have? We need to know that the number of base cases, that's the first thing, we are testing the base cases, and then we perform the recursive case. And as I asked before solving this question, in this particular recursive function, we have two base cases when b equals 0 and when b equals to a, and then I have one recursive case, this particular one. So this is the algorithm. Int cure, integer a and b. If b is 0, return 1, as you can see. Else, if a is equals to b, then return 1, the second condition. Another student could simply come and say if b is equals to 0 or b is equals to a, return 1, it is still correct. So all this block can be reduced to if b equals to 0 or a equals to b. And then finally, the else part, I simply have return q of a minus 1 b minus 1 plus q of a minus 1 b, and if n function. So that is what we have for the Center Regional Mock 2024 question 6 sub 3, and the question was for 6 marks. Next question, Center Regional Mock 2023 question 2 sub 3. Read this section of program code that input 20 numbers and then output the largest number input. So that's the code. We initialize H and C to 0. Then we repeat. Read X. If X is above H, then X becomes H. C becomes C plus 1. Print H until C is less than 20. Now, as a student who went through the channel, who saw how we are writing algorithms, you realize that this conditional stipulated until c is less than 20, it is what we use to track the number of numbers we are entering in our algorithm. And now this condition is for us to know whether a number is actually higher than the presently highest number. And here we see that h is the number we have denoted to store the maximum number, because inside the loop we are reading x, that is, we are reading each of the numbers. Now, what are the different errors? One is the first error here, x equals to h. Since h is the one that should store the maximum number, and if x is greater than h, it means that the new value of x that was entered here is more than the maximum number. So h should store that number to become the actual maximum number. So this line should be h equals to x, because it's not x that stores the maximum number, but it is instead h. The next error is at this level where they say print h, because when you have this print h in the loop, it means that for every value you are going to enter, and that if that value is greater than the maximum number, we are going to print that value. But the program says we output the largest number input, not all the numbers. So at this level, print h should come after the end of the repeat loop. So this h should come after this until loop. So it should be at line 10, or let me say line 9, because if I delete this, this becomes line 8 and it becomes line 9. That's why I did not put the line number, but I instead said print h should come after the end of the repeat loop. The last error is until c is less than 20. When they say until c is less than 20, what do you mean? And c is equal to 0, when you repeat the first time, is c less than 20? Yes, because c become 1 year. Is 1 less than 20? Yes. So it means that this condition stipulates that we are going to enter only one number, which is wrong, because we are supposed to input 20 of them. So the condition here should be what? Until c is equals to 20. So those are the three errors that we had, and those are the correct way they should be implemented for the algorithm to work perfectly well. And that is what we had in Center Mock 2023 for 4 marks. The next one, the Northwest Regional Mock 2024 question 6. So this is a full question that was only on algorithms. So as the question is long, I'll be reading each question and answering directly. The A part says, identify two advantages on the use of iterative functions over recursive functions. So why are iterative function advantageous over recursive function? Simply because they run faster, because they are not using a recursive stack, and they use a lesser amount of space. So those are the two conditions why iterative functions are advantageous over recursive function. They execute faster, and they occupy less amount of space, sorry, because they don't make use of a recursive stack as recursive functions do. The B part says Briefly state and describe two characteristics of a recursive function. So we have the base case, the condition or the statement to stop the recursion, what we call the base case, and the recursive call or the recursive case, the instance where the function calls itself at least once to perform a subtask. So these are the two characteristics of a recursive function. The sub-2 now says figure 1 shows a flowchart of a well-known algorithm, as you can see. This is the flowchart in question. And these are some questions that were asked. And a reality that I had when I marked some script of students in a school who use this Northwest mock as their regional mock, I realized that many students did not attempt this question. And when asked, they just said because the diagram was frustrating, which was a little bit a deception because when a question is given to you, no matter the kind of diagram or illustration that you might have, go through the question and you might see that it is very easy as this question. So that's the flowchart that was given to us. The A part says, identify which algorithm is represented on the flowchart. When you look at the algorithm very well, when you see middle value equals to first plus last divided by 2, then here we compare. If it is true, we output that middle value. If it is false, I compare middle value. Is it less than? Is it greater than? You realize that what which algorithm are we talking about here? We are talking about the binary search algorithm. So that's what you were supposed to give for 2 marks, binary search algorithm. The B part, state the time complexity of the algorithm. For a student who went through the notes, you will know that the time complexity of a binary search algorithm is O, big O to the log n. The C part says which problem solving method is used in the algorithm. So this algorithm, which problem solving method is being used here? It is what? Divide and conquer, because the binary search uses divide and conquer, and recursion. Yes, because the binary search also uses recursion. So that's the answer to the C part. The D part says state the base conditions found on this algorithm. Now on a flowchart, how can you identify the base case? The base case is what makes the algorithm to end. As you can see here, the condition or the statement that stop the recursion. At this level, which condition brings me directly here? We have this one and we have this one. So if Li is greater than Fi, sorry, the reverse of this condition bring us here. So if Li, the reverse of this one is what? Li less than or equals to Fi, it will bring us here. And also this one, this condition, if list at position mi is equals to value, it will bring us to the end. So these are the two base cases that we have here, these two conditions. Remember that this, when this one is true, it brings us here. So this is the base case. Whereas when this is false, it brings us here. So it is the reverse of this one that will be considered as the other base case. That's why we have this. Li greater than or equals to Fi and list at position mi equals to val. So those are the two because the two base conditions of the algorithm. The E part says produce the equivalent representation of this algorithm in natural language. So that indirectly asking you to describe how a binary search works. And how does it work in natural language? If the search item is greater than the middle item, then continue the search in the right sublist of the middle item. If the search item is smaller than the middle item, then continue the search in the left sublist of the middle item, as you can see here. So if the left item is less than the value, we focus on the lower part and we continue the searching. Otherwise, I change the upper bound and I continue the searching again. Then yeah, repeat the process until the item is found. At this position here, until the item is found, or the size of the list reduces to 0. And when does it reduce to 0? When this condition is no longer true. That's all for 5 marks. Another student could decide to produce the pseudocode. As you can see, this pseudocode matches with this one. That's what we have, dear students. So that's what we're expected from students for a whole 17 marks. After the correction, many of them saw how easy this question was. Computer science advanced level, strategic chapters that need a little bit of reasoning does not require much writing, but more reflection and more marks, in contrary to other chapters. An example is algorithm, as you can see, logic, which was already treated, data type and data structure, which is our next chapter. We move. The next question, the last. Southwest Regional Mock March 2025, question 5 sub 1, a question on 7 marks. What is meant by the efficiency of an algorithm? What do we have? The efficiency of an algorithm refers to the resources an algorithm consumes when executing, typically measured in terms of time and space. The B part, they said, for an array of size n, state the worst case time complexity of the following algorithm expressed in big O notation. The worst case for linear search, as the name says, linear, so big O to the n. Binary search, big O to the log n. Selection sort, the precise, considering comparison only. And we consider comparison only, we have big O to the n squared. Under what circumstances does the best case time complexity occur for a linear search and a binary search algorithm when looking for an element in a list? Guys, I talked about this when I was explaining linear search and binary search. I gave you, especially for linear search, when we have the best case and the worst case, and the same thing for a binary search. So what do we have? For a linear search, the best case occurs when the search element is first on the list. Binary search, the best case occurs when the search element is in the middle of the list. That's what a student had to write. 1, 2, 3, 4, 5 lines for 7 marks. And that is all. So we are coming to the end of our past question solving. We proceed with the exercises. We have the Southwest Regional Mock March 2025 question 7I. We have the Bamenda Mock 2025 question 4. And we have GC 2025 question 4. So I am waiting for your solutions either in the Telegram channel or in the WhatsApp channel. Thank you very much and see you next week for our new chapter, data type and data structure. Remember to like, to subscribe, and to share for our community to expand exponentially. Thank you very much. For those who are already contributing for the progress of our channel, thank you very much. At the end of this video, you are going to have a link for an online quiz on algorithms, both for computer science students and ICT students. Thank you very much.